Hello everyone, let's start solving today's Leetcode daily challenge question. So the question is make lexicographically smallest array by swapping elements. You are given an zero indexed array of positive integers nums and a positive integer limit. In one operation, you can choose any two indices I and j and swap nums of I and nums of j if my absolute difference of nums of I and nums of j is less than or equal to limit. Okay, and we have to return the lexicographically smallest array that can be obtained by performing the operation any number of times. Okay, so an array A is a lexicographical smaller than array B if in the first position where A and B differ, array A has element that is less than the corresponding element in B. For example, the array 2, 10, 3 is lexicographical smaller than array 10, 2, 3 because they differ at index 0. Okay, so first understand what's the question is. We are given an array and a limit, and we can do one operation. If my this condition satisfies, then we can swap these two numbers. If my absolute difference of two elements in an array is less than or equal to limit, then we can swap these both arrays. Okay, and we have to return the lexicographically smallest array. That means, what is the lexicographically smallest array? Let's say consider we have array 1, 2, 3, 4, 5, 8, 0, and we have number like 1, 2, 3, 4, 5, 10, 11, 12. Okay, so in this both, which is a lexicographical smallest, here it is given that the first position, if the first position where A and B differ, where which is the first position, this 1 and 2, which differs, and if my here my 8 is less than 10, that means this array is a lexicographical smallest array than this array. Okay, and if we consider both as, let's say we have same elements. Okay, here I'll say 12. If I see this, then which is the smallest? This is my lexicographically smallest array. Okay, so this is what we have to return a lexicographically smallest array that can be obtained by performing this operation, this swapping operation, any number of times. Okay, so if we see this example 15398, and okay, limit is what? Limit is 2. Here, this 1 and 5, what is the difference? 4. So we cannot swap this. 5 and 3, what is the difference? Is 2. As it is given less than or equal to. So we can swap this 5 and 3. So 1, 3 and 5. Now this 5 and 9, what is the difference? 4. So we cannot swap this. Again 9 and 8, what is the difference? 1. We can swap this. So 8 and 9. So here you can see we got our answer. This was a simple thing, okay, which we understood. Now, if you see this example, okay, 1 and 7, what is the limit? Limit is 3. What is difference of 1 and 7? 6. So it will not get swapped. Now 6 and 7, yes. So we can swap 6 and 7. Now 7 and 18 we cannot swap. So 18 and 2, can we swap? No. So 18. Now 2 and 1, can we swap? Yes, 1 and 2 because the difference. Okay, so finally we will get this as our answer. Okay, so we are going to see here, you can see in this example same like limit is 3. There is no element which is the difference 3, and we cannot swap this. Okay, and also here, here if we see this example, let's say we have example 2, 5. Okay, 2, 5 and 4. We'll take some more different example. Let's say 2, 8 and 4. Let's say I'll take here as a 6. 6 will be better. Yeah. Explain this. Okay, so if I swap this, okay, here, okay, let's say not take this example. Directly tell you what we are going to do is here. You can see, okay, in this example we are going to use the sorting technique, and then we are going to use the hash. Okay, so here we can see one. Okay, one. Then let's say here 5. Okay, what was our initial array? 5 and 3. Okay, what's the difference of this 5 and 3 is 2. So we can say this is in the first group. Okay, this is the one is there, and 5 and 3. Okay, this is in the first group. And next is 9. 9 and 3, the difference is greater than your limit. Okay, so we'll add it in another group. Now 8 is in which? We'll add it in this group. Okay, but we are going to use this example, right? Yes, here we'll add in this way. Okay, so instead of adding like this, what we are going to do is first we will take a sorted array, because as we need a lexicographical smallest array. So what is the sorting of this array? This array, let's say sorted array will be 1, 3, 5, 8 and 9. Okay, now we will check like this. Okay, instead of like this. So we will group these arrays into different. So let's say here 1 and 3, what is the difference? 2, and our limit is 2. So we can add this 1 here. Now 3 and 5. Okay, first we will add 1 and then we will add 3. Now 3 and 5. What is the difference? 2. So it is in the same group. Now 5 and 8. What is the difference? 3. But the limit is 2. So we'll make different group and we'll add it here. 8. And what is the difference of 8 and 9 is 1. Then we'll add it 9 here. So we got two different groups. Okay, two different groups. And as we are sorting, here you can see this follows in this group. Everyone follows what? This limit concept. Okay, and in this also it follows this limit thing. Then what we are going to do in our answer, what we will do, we will check. Okay, what we will check this one. Now what was our initial array? This. Now this one we will check in the which group. Let's say this is our zeroth group and this is our first group. Okay, and we will check this is in which group? First group. What is the first element? As we have to return the lexicographical smallest array, right? So that is why we use the sorted array. What is the first element? 1. So we'll insert. Now we will remove this. Okay, now, okay, now what we are going to do is, now 5. 5 is in which group? This group. So which is the smallest element? 3. So we will remove this and add this in our answer. What is my next element? 3. 3 was in which? So for that we have to store, as we have removed from here, right? So for that we will store this 3 belongs to which group? Okay, not no need to check here if it is there. 3 is in the, was this in this, right? In this group. So what was the least element? 5. So 5. Now 9. 9 is in which group? This group. Which is the smallest element? 8. 8. And now 8 will remove, and at the end 8 is there. 8 was in which group? This group. So what is the latest element? 9. So 9. So in this way we will get our answer. So every time we are grouping our elements, okay, so let's say in each group it will follow the limit, and like that we will get what? We will get the lexicographical smallest numbers. Okay, So let's start coding. Okay, yeah. So let's start. First is let's say the nums dot length. First we want a sorted array. So let's say int sorted array, or let's say sorted, I'll say, is equal to new int. What will be the size? N. Now we have to add, insert all the elements, right? Or int I equal to 0, I less than n, I plus plus, sorted of I is equal to what? Nums of I. Now what we will do? We will sort this arrays dot sort sorted. Okay, now we need what? One to store numbers with respective group, and one to store group and its number. Okay, so for the first one we need a hash map of integer comma integer. Okay, I'll say group 1 is equal to new hash map. Now for this, what we want? Hash map of integer means group number and list. In this list, what are the numbers? Okay, I'll say group 2 new hash map. Okay, now two things. Now we have. Now what will be our int key is initially 0. Int group. Instead of key, I'll say group. Initially my group is 0, and in that group, okay, my first element it will be there. So I'll add first element group 1 dot put here it is number and its key. So sorted of 0 and its key will be group. Okay, now in this group 2 dot put key, that means our group comma, what are its elements? So new linked list arrays dot as list of what? Sorted of 0. Okay, so this is our initial thing. That first is our first element will be in the group 0, and here in the group 0 we have right now our first element. Now for from the next int I is equal to 1, I less than n, I plus plus. Okay, I will check what if my math dot absolute of sorted of I minus sorted of I minus 1, if it is greater than limit, then we will increment our key. Okay, we will increment our group number, and we incremented our group number. Then we will add this group 1 dot put sorted of I comma group. Okay, now we will check if my group is present in group 2 or not. If my group 2 dot contains key what? Group. If it is there, okay. If it is not there, then we will put group 2 dot put what? This group with new linked list, and we will insert group 2 dot put group comma group2 dot get group dot add sorted of I. Okay, now we will get our group 1 and group 2. Here we discussed, right, our group, this will be our group 2, group 1 will be like this element which key. Okay, now for int I is equal to 0 I less than n I plus plus, our normal array we are traversing, so int my current will be nums of I. Okay, now I will check that current element is present in which group. So int group is equal to group 1 dot get this current. Okay, now we will, what we will do, we will update this with the latest element of what, group 2 dot get this group. Okay, dot pop, and at the end we are going to return our nums. Okay, there's some issue, let's see. Variable group is already defined in the Mexico. Okay, left 5. Okay, already we defined group. Okay, so here I'll say group num. And where is the another error? Line number 50 income group 2 dot put. Okay, so instead of put, what we will do is we can directly do like this, right? We don't need to do. Okay, let's run. Cannot find symbol. Okay, we are using linked list. Here we will use the linked list, not the list. Okay, let's now try. We were using the just, yeah, here you can see accepted. Let's submit this. Yeah, yes, you can see the solution got accepted. So in this way we can solve this question. If you feel this video is helpful to you, please like this